Hi, this is going to walk you through the number 6 practicing recursive and explicit equations answer key pretty fast. If you need to pause and study the answer key and come back, you might want to do that too. So first, how many pieces of candy are there total? So if I have 15 pounds, I'm going to multiply that by 180 pieces for each pound. I'm going to get out 2,700 pieces of candy. Now, when I'm doing an explicit and recursive equation, I like to make a graph first. So I'm going to pop over here to Desmos. And so on the zero, without any quarters, 0, I have 2,700, 2,693, subtract 7 to get the next day. So if I want to do the 5th quarter in, then I would be at 26, 72 minus 7 is 65. Now I can't see this on my graph. I'm going to go over my wrench because I can actually pick this. My x's, I like to have my x's have a little negative so I can still see that. And then I'm going to go to I'm just going to do 10 quarters. So this is quarters in. And then my y-axis, I go all the way up to 2,700. So I'm going to actually go to 2,750. And so then this is candies left. And you can see I get pretty decent graph, but that almost looks like a straight line because I want to zoom in on here. So I'm actually just going to make my y-axis not go all the way to negative numbers, but I'm going to go to maybe 2,500. Yeah, that looks a lot better, right? Okay, so I can sort of see how this is going down 7 each time. So then I'm going to go back here. I'm going to write my explicit equation. So candies is going to start with 2,700. I'm subtracting 7 for each quarter. So I might use Q for that input. Or you could also, if you like starting it with you could use C equals 2693 if you like starting with the first term. And I'm subtracting 7 n minus 1 times. Okay, so either one of those are both equivalent. I could do a quick distributive property to get back up to this one. Then for my recursive routine, so remember I'm always just starting with my first term. So this is what you have to be careful with. Your first term is 2693. You could have also started with, you could write this as a sub 0, which is your 0th term is 2,700. Those are both okay. And then I'm going to say to get to my next term, I'm going to use the term before or the n minus 1 term, and I'm going to subtract 7. So notice how I have this minus 7 here and I have minus 7 over here, and talking about where I'm starting either the 0th term or the first term, and I could input my table and graph here. Okay, there's a lot of different types of forms of answers for these if you go and look at the answer key for them. Okay, and then for Augustus Gloop, so once again, hey, he's starting, so you got to say where I'm starting with for the recursive routine. So a sub 1 equals 10. You could have also written this as a1 equals 10, that would be an okay write it. And I'm going to say a sub n equals a sub n minus 1. So any number is going to be the number before it. I'm going to add 10 to it. Okay. So then for my explicit equation, so any number in my sequence, a equals 10 plus, and I'm adding 10 n minus 1 times, or if you do some distributive property, you multiply in the 10, you subtract out, this just equals 10n. So 10 times the number of days. So then to figure out how many he had on day 30, so day 30 would just be 10 times 30, which would be 300 candies. Not a bad deal for doing your homework. Okay, but that should be a pretty simple, straightforward one. There's a bunch of different forms of these, and they all show up in the answer key. If you go back and look at that, this might be a good time to pause and go back and look at that answer key. So now if I'm modeling 1 candy in the first day, 2 on the second day, so now I'm doubling. So on the first day, he has 1 candy. And then on any day, he is getting, you take the day before, the n minus 1 day, and you multiply that by 2. So when you're thinking about the explicit, this would look like 1 times 2 times 2 times 2 times 2, and you're doing this over and over. So an explicit just shortens that formula up. So I'm going to write this as a sub n, or a equals 1 times 2 to the n minus 1 power, because I'm doing that repeated multiplication becomes an exponent. If you want to use the 0 term, some people like using this 1/2 times 2 just to the regular n power. And then I can plug in 30 into my explicit formula here to figure out how many he has on day 4.